Welcome to a lesson on graphing planes. To graph planes by hand, it is often helpful to make traces where the plane intersects each coordinate plane. So we'll take a look at where it intersects the XY plane, YZ plane, and XZ plane. These are called traces. So to determine the XY trace, we'll set Z equal to 0. To find the YZ trace, we'll set X equal to 0. And to find the XZ trace, we'll set Y equal to 0. Then what we'll do is we'll combine these three traces onto the XYZ coordinate system to make a graph of the plane. Now, if an equation of a plane is missing a variable, the plane will be parallel to the axis represented by the missing variable. Let's go and take a look at a couple of examples. Now I should mention we could just go ahead and plot the intercepts on the three-dimensional coordinate system, but since we will be graphing quadric surfaces very soon, I wanted to introduce this technique now because we'll use it again for quadric surfaces. So to determine the XY trace, or where this plane would intersect the XY coordinate plane, we're going to set Z equal to 0, and that'll form the line x minus 2y equals 6. Now to graph this line in standard form, we can go ahead and find the intercepts. If we set y equal to 0, x would be equal to 6. That would be our x-intercept. If we set x equal to 0, y would have to be negative 3. That would be our y-intercept. So this plane cuts the xy plane along this line here. To determine the YZ trace, or where the plane intersects the YZ plane, we'll set x equal to 0. That'll give us the line negative 2y plus 3z equals 6. Notice how we have changed the orientation of the axes. This is now the y-axis. This is now the z-axis. So if we set z equal to 0, y would have to be negative 3. Now this is the y-axis here, so we'll be over here 3 units. Notice the y-intercept is the same in the xz trace as it is in the xy trace. Now if we set y equal to 0, z would have to be equal to 2, so our z-intercept is positive 2. So the given plane intersects the yz plane along this line. And then lastly, to determine the xz trace, we set y equal to 0. Well, if y is 0, we'll have the line x plus 3z equals 6. So our x-intercept will be 6 again. And the z-intercept, if x is 0, would have to be 2. So this plane intersects the xz plane along this line here. So now that we have all of the intercepts, we can go ahead and plot them on the 3D coordinate system to sketch this plane. So we can see the x-intercept will be positive 6, so we'll go out 6 units along the x-axis. This point here is on the plane. The y-intercept is negative 3, so we'll go to the left 3 units. This was 6. This point is on the plane. And then lastly, the z-intercept is positive 2, so we'll go up 2 units. And now we'll form a triangle with these 3 points. And then we'll go ahead and shade this. And this gives us an idea how that plane looks in 3 dimensions, showing where it crosses each axis as well as the XY, YZ, and XZ traces. Now it is a little bit challenging to give a 3-dimensional perspective on a flat surface as we see here on the screen, but this is pretty much the best we can do by hand. Let's go and take a look at one more. Here we have 3x plus 2y minus 6z plus 9 equals 0. So to determine the xy trace, we'll set z equal to 0. That'll give us the line 3x plus 2y plus 9 equals 0. I'm going to go ahead and move the 9 over to the right side, so this will equal negative 9. So if we want to find the x-intercept, we'll set y equal to 0, so the x-intercept will be negative 3. And if we set x equal to 0, we'd have 2y equals negative 9. If we divide both sides by 2, we'll have y equals negative 4.5. So somewhere down in here. So the given plane intersects the xy plane along this line here. To determine the yz trace, we'll set x equal to 0. So we'll have the line 2y minus 6z. Again, I'll move the constant to the right side, so we'll have negative 9. So if we want to find the y-intercept, we'll set z equal to 0. So we'll have 2y equals negative 9. Well, we already found that on the other graph, so we know the y-intercept is negative 4.5. Here's the y-axis in this trace. So we're back here at negative 4.5. To find the z-intercept, we set y equal to 0. So we'll have to divide both sides by negative 6. Negative 9 divided by negative 6 is going to give us a positive 1.5. So the given plane intersects the YZ plane along this line here. And then lastly, to find the XZ trace, we set y equal to 0. So we'll have the line 3x minus 6z equals negative 9. Again, setting z equal to 0, the x-intercept would be negative 3, which matches what we found up here. And then setting x equal to 0, z would be positive 1.5. So we've shown where the plane intersects the xy plane, the yz plane, as well as the xz plane. Now we'll go ahead and sketch it on the three-dimensional coordinate system. So again, here's our x, y, and z axes. So the x-intercept is negative 3, so we'll go back 3 units. This point is on the plane. The y-intercept is negative 4.5. So we'll go left 4.5 units, somewhere in here. And then lastly, the z-intercept is positive 1.5. And I'm going to go ahead and change the scale on this so we can make a nice triangle. We'll call this 1 and we'll call this 2. So here's 1.5. We'll go ahead and form a triangle using these 3 points. The sides of the triangle represent our traces, and if we go ahead and shade this triangle, this would represent where the given plane intersects each axis. Okay, that's going to do it for this video. I hope you found this helpful.